Hey all, this is Paul. Greetings. This is my fifth e-record for the fifth exercise of Data Structures Lab, and the program that I've been given is to implement a single linked list, and I've used the same data structure before in the previous records. So let's just move to the code. This is the code that I've created. I have declared necessary header files, and then I've created a struct node, and with int data and node pointer link, and I've created the necessary functions, and I've declared the global pointers node pointer head equal to null and pointer temp and pointer monkey. The use of these pointers will be explained later in the code. Now let's move on to int main. In int main, I declare the necessary variables, and I start a while loop for the to ask the user whether he wants to continue, and then I ask the user what choice he wants, whether he wants to insert the data at the beginning, at the end, or at any position of the linked list, or does he want to delete an item or display the list, or search a particular item in the list. Now I take in the choice of the user using a switch case statement in the variable of switch of ch, and then based on the cases, that's the choice of the user, I call the necessary functions. Then let's move on to the functions that I've created. The first function is to insert the data at the beginning. In this, that's data beg of int of item, and then temp equal to new node. I create a new node and I check whether the memory is full. If so, I can't do anything. If not, I do the simple insertion, that's temp arrow data equal to item, and temp arrow link equal to head. I make it point to head, and then head equal to temp. Then void disp, that's to display the list. I use a monkey pointer in this case. I make it point to head, and then if head equal to null, that list is empty. If it's not so, then while monkey not equal to null, that's as long as monkey goes to the last item, I print the data of the each node, and then I increment the position of the monkey pointer. That's I make it move to the next part, and then the next function is to insert the item at the end of the linked list. I create a new node and I check whether if it's empty. If it's empty, then I directly insert it. That's same as the first function. And then else, if it's not empty, then I make temp arrow data equal to value, and temp arrow link equal to null, and monkey equal to head, and I use monkey pointer to find the last item of the list. That is by the condition that monkey arrow link not equal to null, and that is the last item always points to null. So monkey is sent in an iteration so that it finds the last item. When it's found, then the swapping takes place. That's monkey pointer link equal to item. The last part is pointed. And then next one is to insert the item at after a particular position. That is, I create the new node, then I check whether if it's empty, then I print that list is empty, and then temp arrow data equal to value, and temp arrow link equal to null, and head equal to temp. That's I directly inserted. There is no item to find. Else, that is, in case there is items, then I ask the user after which item he wants to insert the element, and then that is taken in, and I use the monkey pointer to compare the data of the each node with the item given by the user, and when the position is found, then the normal insertion takes place, and then I change the position of monkey pointer, and in case then I use a counter C to find the position of the item. In case it still remains 0 after full iteration, then the position is not found. And next one is to delete the data. In this case, I check whether the list is empty. If so, you can't delete anything. Else, if it's not empty, then temp equal to head equal to head arrow link, and item equal to temp arrow data. As I move the position of head, and I store the first element in a decoy, that's temp, and then I delete the temp, so the memory is freed, and then I return the item. Next is void search data. Int item and c is equal to 0. I have declared these variables, and then I check whether the list is empty. If it's not so, then I ask the user to enter the element he wants to search, and then I use the monkey pointer to locate the element the user wants, and if it's found, then using counter C the position is printed, and then the monkey equal to monkey arrow link. Monkey is made to move to the next. Each iteration it keeps on checking with different nodes, and then after the whole iteration, in case the element is not found, then C remains 0. That is, the control doesn't enter this part. In that case, sorry, the element not found, and I print that the element is not found. That's the end of the code. Now let's just try running it. The compiler is asking me my choice. Let me try displaying. The list is empty. Yes, I want to continue. Let's try deleting. Again, list is empty. The item is 0. Yes, I want to continue. Let's try inserting at the beginning. Data to insert, let it be 20. You want to continue? Yes, I want to continue. Let's try insert. Let's try displaying that my item has been inserted at the beginning. Yes, I want to continue. Let's try inserting it from the end. That's that's 3. And data to insert, let it be 60. Yes, I want to continue. Let's try displaying. Yes, it's inserted at the end. Yes, I want to continue. Let me just try one more, that is insert anywhere, and the item to insert, let it be 50. Insert item after 20. Yes, let's try displaying it. Yes, 50 is inserted after 20. Now let's try deleting it. Enter item to insert. Okay, 24 after 50. Yes, I want to continue. Now let's try deleting it. It's 20. Yes. Let's try displaying the queue. The list. Yes, the item has been displayed. That's it. All my functions work perfectly. Thank you all for watching. This is Paul signing off. See you all next time. Thank you all for watching again.